Hello, welcome to My Space Maths. We've got a fun challenge one today. I would like to invite you to come time traveling with me back to my younger days and see how much my maths has improved. So picture the scene, it's 2003, a young 16-year-old guy
That's me.
is about to sit his first A-level exam. So you might have questions about that. What's going on? Why are we sitting exams in January? So under my system, when I did A-levels, we did modular exams. You would sit 6 exams per A-level, sometimes in January and in the summer. Because I did maths and further maths, I ended up doing 12 maths exams, plus a couple of bonus ones just for a bit of fun. Good times. So this was the first one of my A-level exams that I sat back in January 2003. So it's my first chance to see how I was getting on. So now is your chance to see how you think it compares to your maths exams that you will sit at the end of your 2 years. So I've got a challenge for you today. I'm going to do this as quickly as I can. I've got my timer all ready to go. If you click the link in the description, you can put your email in and we will send you a PDF copy of a shadow paper. So it's exactly the same setup, exactly the same structure, and you can have a go and record how long it takes you to do it. And you can put your time in the comments and see if I need to up my game or if I'm getting slow in my old age at this point. Okay, so I think we're all set and ready to go. I've got my calculator already. I mean, this calculator is far more advanced than the calculator I had when I sat my maths exams, but I'm going to try and use it as little as possible because it is going to slow me down having to type stuff into my on-screen calculator, but there's probably going to be some stuff. I haven't seen this paper for 23 years. Who knows what's on it? I can't remember. It's all very different, the way it was all structured. So I think everything's ready. We're all set. I'm going to go with, so this would have been an hour and a half paper, 90 minutes to get 75 marks. So all the exams are always 90 minutes and 75 marks. I think I can do this now probably in about 20 minutes or so. Okay, that's my guess. We'll see. It's a good target to aim for, reasonably efficient. Okay, so I think I'm all set and ready to go. So I'm going to start my timer in 3, 2, 1. Off we go, and we're going to go with question 1 and see what is happening. So I'm just going to write straight on the paper. We had answer booklets back in the day. So I'm going to differentiate this. I'm just going to write here. So if I differentiate that, 7 goes, 10 times 3 over 2 would be 15, and then take 1 off the power would get me a half. There we go. Look, 2 marks down. We're off to a good start. If I integrate it, that would turn into 7x. I would add 1 to my original power and then divide. I will simplify after and then make sure I get my plus c. And so 7x plus 10 over 5 is 2. It's going to be 4 x to the 5 over 2 plus c. There we go. First question done. It's going well so far. Question 2. Right, I've got a sketch, a sine graph 0 to 360. I'm going to use this line on the paper as part of my axes. There we go. Look, so this is my x, this is my y. So it's moved left 30. So it would normally start the origin. So it would start somewhere over here. So it's going to start somewhere on the axis down here. And then it needs to go back up and have an extra little bit on the end. That would be my 360 there at the end. And then this would be my 0. And it would go up to 1 and down to -1 like normal. And part B wants me to, all right, so part B wants me to do the coordinates. So I won't put them on the diagram. So if x was 0, that'd be my y-intercept sine 30, so it'd be a half. So I have 0, a half, where it meets the y-axis. And then it would normally be 180, but it's moved 30 left, so it would be 150. I can do maths in my head. And then it would normally be 360. It's moved 30 degrees to the left, so it would now be 330 degrees. There we go, 330. Fine. There we go. There's my coordinates where it would meet all the axes. I mean, I could add those on my diagram, maybe. I'm wasting time, wasting time. So we're going to solve this equation. So inverse sine of -1/2 would get me -30. I need to find my other solution. So 180 minus minus gets me 210. And then add 360 onto that gets me 330. And I'm going to take away 30 from all of those. So I get 180 and 300 as my 2 solutions for that equation. There we go. Job done. Question 2 done. Question 3. I mean, that's basically GCSE, isn't it? So we can write 3 to the x equals 3 squared. We're changing the base to then hopefully, and then we can see if I multiply my power of a power, multiply them, gets me 2y minus 2. So therefore, x must be 2y minus 2. Powers have to be the same. There we go. It's pretty straightforward. To solve these equations, I'm just going to go straight in and sub this x in here. So I've got 2y minus 2 squared, y squared plus 7. Expand that, 4y squared minus 8y plus 4y squared plus 7. So I get 3y squared minus 8y minus 3. Wouldn't have fancy quadratic solving calculators back in my day. So we'd have to factorize everything. But that did mean that normally it would factorize. So that is the slight win. So 3y, I need a minus 9y plus 1y. Yeah, that works. So y equals minus a third, y equals 3. I need x values. So if I go and find x equals 2 times minus a third minus 2, minus 2 thirds, minus 6, minus 8 thirds. And then x equals 2 times 3 minus 2. 6 minus 2 is 4. So I'll write them out really carefully just to make sure. So x equals 4, y equals 3. That's one pair. And then x equals minus 8 over 3, y equals minus a third. It's my second pair. There we go. 3 questions done. Under 4 minutes. Not going too badly so far. Geometric series. This is now in A level, like year 2 maths. So geometric series has first term, so that's A, sum to infinity, and show common ratios minus a quarter. So my formula is my sum to infinity equals A over 1 minus R. So we have 1 minus R equals 1,200 over 960. So it'll be 1 minus that. So that does simplify. 120 over 96, both are multiples of 24. So 5 over 4, swap that around, gets me R, and that's minus a quarter. There we go. Job done. So that's sorted. Find 3 decimal places. This is calculator, isn't it? 3 decimal places. So the difference between the 9th and 10th terms. So my 9th term is 1,200 times minus a quarter to the power of n minus 1, so that's 8. And my 10th term, 1,200 times minus a quarter to the power of 10 minus 1, or 9. And the difference between them is therefore going to be 1,200 times minus a quarter to the power of 8 minus a quarter to the power of 9. Okay, so I'm factorizing the 1,200 out. So I need my calculator for this. So I'm going to save myself some time, I hope, by doing minus 0.25 and putting that in my answer button. So now I do 1,200 answer to the power of 8, and then minus answer to the power of 9. Strategically save myself some time. So I get 0.02, what we're doing, 3 decimal places, 3. There we go, that's that one done. So part C, expression for the sum of first n. So Sn is A 1,200, 1 minus R to the n, all divided by 1 minus R. So we get that. Now, when this happens, this bit is your sum to infinity. It's a useful little simplifying trick, that one. That's A over 1 minus R. So I already know that's 960, 1 minus a quarter to the power of n. See, save myself some time. It's all about being efficient. And then prove the sum of the first n terms of the series is this. Oh, sorry, given that n is odd. Right, okay, so n is odd. So n is odd, which means minus a quarter to the power of n would be the same, because it's odd, it would always be negative. We know it's negative, so I can then take that and say that, right? So that must be true. So now if I do that and do 960, 1 minus 1 quarter to the power of n, as my Sn would then be 960, 1 plus 0.25 to the power of n, because n is odd. There we go. Question 4 done. Not bad. 6.5 minutes. It's going well, I think. I don't know. I don't know if I'm on track for my 20 minutes. So on the journey, average speed is given by this. Cost per kilometre, c pence. Fine. Show all calculus. Stationary, right? So see that. We're going to differentiate. So I'm not wasting time. That's v to the minus 1. So it's 160 over v to the minus 2, or v to the minus 2, so over v squared, plus 2v over 100, so v over 50. I want stationary, so I need to equate that to 0 and solve that. So v over 50 equals 160 over v squared. I'm going to carry on over here. So that'd be v cubed equals 16 times 5 is 80. Add on 2 zeros, so it's 8,000. And I think the cube root of that is going to be 20. I'm going to check that. I think it's 20. Just making sure I'm not making assumptions. 8,000. Yeah, could have saved myself some time there. Wasting time. V is 20. So there we go. We've done that. Found the value of v. Job done. Justify as a minimum. So D2C dv squared equals, so times by minus 2, 320 over v cubed, that'd be v to the minus 3, plus 1 over 50. I can already see that's positive, but I will put my 20 in. It's going to cost me a few seconds, but just to make sure it's very thorough, 320 over 20 cubed plus 1 over 50, and then see what that gets me. So I already have 20 in my calculator, so 320 over answer cubed plus 1 over 50 equals 3 over 50. Remember, I don't care the number, it's positive, therefore it's a minimum. Sorted. Find the minimum value of C and hence find the minimum cost of a 250 kilometer car journey. Minimum value of C, so that's when V is 20, so 160 over 20 plus 20 squared over 100. That gets me 8, that gets me 400 over 100 or 4, so it's 12p pence per kilometer, so p per kilometer, so 0.12 times 250, put it in pounds, probably going to make more sense. So 0.12 times, was it 250, 30, that makes sense, £30. There we go, question 5 done, sorted. 6, coordinate geometry, pretty standard stuff for A-level maths. So straight line L1 equation 300 crosses the y-axis at point P. Point Q has coordinates of the midpoint of PQ. So P, y-axis is 0, minus 2. So the midpoint is going to be 0 add 5 over 2 is 5 over 2. And minus 3 add minus 2 is minus 5, also over 2. There we go, that's my midpoint, sorted. L2 is perpendicular to L1. So my perpendicular gradient is minus 2/3. And then it's point Q it passes through, so that's this one. So y minus minus 3 equals minus 2/3, x minus 5. Don't like fractions, 3y plus 9 equals minus 2x plus 10. And then form ax plus by equals c. That's a weird one. 2x plus 3y equals, I need to move the 9 across to make 1. There we go. That's now in the correct form. With integers, fantastic. Calculate the exact coordinates of R. So I need to solve these simultaneously. I am going to just sub in the first equation for y equals into the one I just found, equals 1, like that. Fractions again, times by 2. We'll get rid of that. So now that makes it 9x. That would normally be minus 6, but I times by 2, so minus 12. And then times by 2 gets me 2. So I've got 13x equals 14. So x equals 14 over 13. 14 over 13. And then y equals 3 over 2x minus 2. So that gets 21 over 13 minus 2. That'd be 26 over 13. So minus 5 over 13. So my coordinates for R are 14 over 13 minus 5 over 13. Job done. Question 6 finished. Question 7. Weird shapes. Cross-section. M is midpoint. AD is 28. And then we've got coordinates that we can add on. There's a lot going on. Show the length of BM is 25. So B is 724. And I want to show that BM is 25. I can make a right angled triangle, which then means that's now 7 on either side. And I know that's 24 because of the coordinates. So now it's just BM squared equals 7 squared plus 24 squared, which is 49 and 576. You get to recognize these Pythagoras ones, which gets you 625, and the square root of 625 is 25. I've probably written more than I needed to there. Millimeters. Let's make sure we put some units on. So that's 25. So 25. So which means that's 25. These triangles are all the same. 14, 14 with the same height. Yeah, these are all the same. So show that BMC is this one. I can make a triangle across here because that was 21, 24 was point C. So therefore this is 14 across there. Cosine rule, right, fantastic. So cos theta equals b squared plus c squared minus a squared over 2 times b times c. That's 5. So cos theta equals, I can find that, this is calculator, it's going to slow me down, 25 squared times 2 minus 196, just trying to try and save some time, over 50 times 25. Gets me that, 0.8432. So inverse cos, but I'm in radians. Remember, that's year 2 now. You see, it used to be on P1, so I need to be in radians. Option 4, inverse cos of that value. Yes, fantastic. 0.5675 and so on, which is 0.568. Fantastic. Right, the area. So area, what have we got? We've got 2 triangles. All these triangles are the same, so that means now this is the same angle because they're all 14 across and sides of 25, so I know all of these angles are the same. So I've got 2 triangles and a sector. So I have 2 triangles, which are a half A, B, sine C in radians, so 0.568. And then I have a half times the radius of my sector squared times theta in radians. Year 2 stuff, that one. 2.5 cancel out, so that means now I can sit on my calculator. So I've got 25 squared times sine of that answer I just had plus 0.5 times 25 squared times that angle I just had, and we get 513 millimeters squared. And that's our area, and then the volume. Given this chocolate bar's length 85, right, okay, so 513 times by 85 gives me a volume. All right, 85. 43636.56205, probably written down more than I need to, but centimeter cubed, so therefore volume equals 10 millimeters per centimeter, so it would be 1,000, 10 cubed. So divide by 1,000 would be 43 points, so 44 to the nearest centimeter cubed. Sweet, right, there we go, awesome. So that was that question. Question 8. We've got a diagram, right? Okay, fine. Curve. Points A and B have x coordinates 5 and 10. What are the y coordinates? Okay, so we just sub them in. Y equals 5 squared over 25, which would be 1. Y equals 10 squared over 25, which would be 4. Fine. Okay, 1 and 4. Find an equation of the tangent to C at A. So A is the 5, 1 point we've worked out. That's A. We need our gradient, so dy by dx equals 2x over 25. X equals 5 means that dy by dx equals 10 over 25, or 2/5. And then I'm just going to write my equation. So y minus 1 equals 2/5, x minus 5. That is an equation. Sweet. So that's that question done. Finite region R is enclosed by C, the y-axis, and the lines through A and B parallel to the x-axis. Yeah, that's on the diagram. Express x in terms of y. So y equals x squared over 25. So 25y is x squared. Root that would be 5 root y. There we go, it's point C. Part C even. And then last one, use integration to find the area of R. Nice. Oh, good question this. So this, we worked out our y coordinates, 1 and 4. Yeah, it was 1 and 4, part A. We can do integration, and we swap it all around and do it with the y's because it's bounded by the y-axis. So to work out R, we can do the integral of 5 root y, but I'm going to write it as y to the half, with respect to y, between my y limits of 1 and 4. And that will get me the area of R. And I've just noticed it says end, 17 minutes. All right, okay, let's go. So 5y, 3 over 2, over 3 over 2, square brackets because I've integrated. Simplify that, 10 over 3, so 10y, 3 over 2 over 3, 4 and 1. Sub those in, so 10, 4 to the power of 3 over 2 over 3 minus 10, 1 to the power of 3 over 2 over 3. 4 square root is 2, cube it is 8, times by 10, 80 over 3. The 1 will just be a 1, 10 over 3, and we get 70 over 3. That's my answer. Quick, stop, 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 stop. Yeah, right. 17 minutes and 42 seconds.
Not bad, not bad.
90 minutes that exam was, you were allowed for that exam. Now, I don't know, maybe I've improved slightly. I don't remember completing it in 17 minutes and 42 seconds 23 years ago, but there you go. I'm not sure how long it did take me. I'm going to assume I got it all right. I don't think there was any obvious bits where it was a bit unsure. I've got my equations and all sorts, so I think we're okay. So, let me know in the comments if you thought that was easy. If you think that's now much easier. Now remember, there would be 5 more exams I would need to sit. That is not my A-level maths. That is part of my A-level maths. So just to be clear about that. So I know that might seem easy, but it does get a bit more difficult. I might have to go and dig out some of those other papers. Okay. But remember, so you can now challenge me and see how your maths efficiency and speed compares. So if you click the link in the description, and put in your email, we will send you a shadow paper of this same thing. So you can't have the same paper, obviously, because you've seen all the answers, but the ideas are all there. It's the shadow paper. So you can have a go, record how long it takes you, and then put that in the comments, right? And you can let me know if I need to up my game or if my old age is now starting to slow me down. I mean, I had a little bit of time. I had to type stuff in the calculator. You've got your desk calculator, so maybe I've got a few seconds I could shave off. And I talked a lot, but I don't know. I'm reasonably pleased. I think that went quite well compared with how I would have gone back in the day, 23 years ago. So remember, if you've enjoyed that, if you think that's something that's kind of helpful and it's good to see and you want to do the challenge, remember to hit that subscribe button. Lots of content from us here at MySpace Maths, helping you guys out with A-levels and GCSEs, maths, further maths and all sorts. And give it a like as well, so then more people can watch and enjoy. Okay, so remember to put your time in the comments. I'll keep an eye out and see if there's any that are kind of pushing my sort of time. And let's assume you're going to get it all correct, so you won't run into any errors. All right, awesome job, everyone. I look forward to making some more stuff for you guys. I'll see you all soon.